You ever wonder how we go from being a baby, barely able to grab a rattle, to an adult who can tackle something like abstract algebra? I mean, how does a mind actually grow? Well, for a long, long time, one name has been right at the heart of that question, Jean Piaget. And today, we're going to unpack his incredible, groundbreaking theory of cognitive development.
So let's start with a really basic question. Are kids just mini adults? Smaller, less informed versions of us? For the longest time, believe it or not, the answer was basically, yep. The whole idea was you just had to pour information into their little heads. But then, this one Swiss psychologist came along and just completely turned that idea upside down.
In this quote right here, it just perfectly captures his whole point. See, Piaget realized that kids aren't these empty buckets we're supposed to fill with knowledge. No way. They're active builders. They're like little scientists, constantly running experiments, testing things out, and literally building their own understanding of the world. And let me tell you, at the time, this was an absolutely revolutionary idea.
Okay, so if kids are building their own knowledge, how do they actually do it? Well, Piaget's big idea was that this whole construction project doesn't happen randomly. Instead, he saw it as a journey, a path that we all take through 4 very distinct stages of mental growth. The best way to think about it is like a developmental staircase. You've got the sensorimotor stage, then the pre-operational, then concrete operational, and finally, formal operational. And here's the key. Every single child climbs this staircase in that exact order. Now, the ages might be a little different for each kid, but the sequence, that never changes. You absolutely cannot skip a step.
All right, let's start at the very bottom step, the sensorimotor stage. This is from birth to about 2 years old, and it is all about the senses and moving around. A baby learns about the world by touching it, tasting it, grabbing it. When they shake a rattle, that's not just them being cute. It's a full-on experiment in cause and effect. And the huge breakthrough here is something called object permanence. That's the moment they realize that when you hide a toy, it hasn't just blinked out of existence. It's still there. That is a massive, massive mental leap.
Okay, next up, from around 2 to 7, we hit the pre-operational stage. This is where things get really fun. It's this explosion of language and imagination. A cardboard box isn't a box. It's a spaceship. A banana is a telephone. But, and this is a big but, the thinking here is all intuitive. It's not logical yet. And it's famously egocentric, which means a kid at this stage really struggles to see the world from anyone else's point of view but their own.
Then, from about 7 to 11, boom, logic finally enters the picture. This is the concrete operational stage. Now a child can start to think logically, but it's about physical, concrete things. They can finally understand that a tall, skinny glass can hold the exact same amount of juice as a short, wide one. They start to really get math, and they can sort things into different groups. But again, all this logic is still tied to the real, physical world they can see and touch.
And finally, we reach the top of the staircase, the formal operational stage. This kicks in around adolescence and goes on from there. This is where our thinking completely breaks free from the physical world. Now we can think about abstract ideas, things like justice, or love, or infinity. We can think systematically, come up with hypotheses, and really dig into those what-if questions. This, right here, is the foundation for all scientific reasoning and serious problem-solving.
So, there you have it, the 4 stages, but that leaves a big question, right? What's the engine that's actually pushing us up that staircase? How does our brain actually build these new ways of thinking? Well, Piaget had a really elegant answer for that, too.
It all boils down to this one core idea called a schema. Think of a schema as a mental filing cabinet. It's a little folder in your brain that helps you organize and understand information. So you have a schema or a folder for dog, one for chair, one for going to a restaurant. It's basically how your brain sorts everything it knows. These are the absolute basic building blocks of our intelligence.
Okay, so what happens when you come across something new? Well, the first thing your brain tries to do is called assimilation. So let's say a little kid has a schema for dog, right? The file says 4 legs, furry, has a tail. Then they see a poodle for the first time. It checks all the boxes so they can just pop that new information right into their existing dog folder. That's assimilation. Easy peasy. But what happens when something doesn't fit? So the kid sees a cat. It's furry, 4 legs, has a tail, but hold on. It meows, it doesn't bark, and it's climbing a tree. This just doesn't compute. It creates this mental confusion, which Piaget called disequilibrium. The old dog file just isn't working anymore. So to fix this, the kid has to do something called accommodation.
They have to change their thinking and create a brand new folder, a new schema just for cat. And that moment of reorganizing your brain, that's where the real deep learning happens.
Now, look, Piaget's theory was an absolute game changer, but, science is always moving forward. So over the years, other researchers have put his ideas to the test, and they found some things that need a bit of an update. So it's super important to look at the critiques too.
So what's really fascinating here is how modern research adds some nuance to Piaget's big ideas. For one, it seems like Piaget might have actually underestimated what kids can do, maybe because some of his tests were a little too complicated. We also now know that a kid's thinking isn't always at one single stage. They might be thinking at a concrete level when it comes to math, but still be in a pre-operational mode when it comes to understanding social situations. And maybe the biggest thing is that with good teaching, kids can often grasp concepts way earlier than Piaget thought. So it's less like a rigid staircase and more like overlapping waves of development.
Okay, so what's the big takeaway here? Why are we still talking about a theory from decades ago? I mean, what does this all mean for us right now, especially when it comes to learning and education?
Well, his ideas walk right into the modern classroom. I mean, think about it. The whole idea of adapting lessons to a student's developmental level, that's pure Piaget. Using blocks and physical objects for younger kids, yep, that's him too. Using familiar examples to explain something tricky or encouraging kids to just explore and figure things out for themselves, what we call discovery learning, it all comes from this core idea that kids are active builders. We're not just supposed to pour facts into them. Our job is to create the environment where they can build their own understanding.
And get this isn't just about kids. Here's a statistic that might actually surprise you. One study found that only about 35% of high school graduates in industrialized countries fully reach that final formal operational stage. Think about that. It means for a whole lot of us, even as adults, developing that kind of abstract, higher-level thinking is still a work in progress.
And that really leaves us with a final and I think pretty powerful question. If we accept that the mind is something that is built, not just given to us, and that its full development isn't even guaranteed in adulthood, well, that changes everything about how we should think about learning. It's not just something for kids in school. So the real question for all of us is this: how can we, as parents, as teachers, as friends, and just as lifelong learners ourselves, get better at supporting the construction of a more thoughtful, more logical, and more creative mind at every single stage of life?